So we have a square matrix, n by n matrix. We want to rotate it 90 degrees clockwise, and the performed rotation should be in place. So it should be modified directly without allocating another matrix. It should only return a modified input matrix, and we have these examples. So this rotated clockwise, notice, pay attention to 1 here. Notice where it is. It moves here, 2 moves down here, 3 moves down here, like that. And everything moves accordingly. And same thing here. 3 is gonna be here, 6 is gonna be here, right? Everything is just, it's like you twist, kind of like if you're on your touchscreen phone, you're editing the image. And then if it's 3, it's just one thing. There's nowhere to go, so it's just 3. Okay. So yeah, real world application, super relevant. And now for the solution is interesting. It's all this blob of text. But I find the diagram more useful than that. So let's just look at that. So from the beginning, what's going to happen is we're going to take notes of pay attention to the corners. Okay? And what's going to happen is this place is going to, because we're going clockwise, this is going to be the linchpin for the whole thing. And we're going to swap first here, then here, then here. Okay? Here, so I'll take it again. I'm going to swap here, then here, then here. And then, so we do that, we do that. Now pay attention to these two. We do that, okay? In fact, let me make this a bit bigger. All right, let me take from the top. Pay attention to these. Swap these, and then swap these. Boom. And then what's gonna happen is we've done that, so we're gonna move inwards by 1. Boom. This is gonna be the linchpin again. Swap this, then swap this, then swap this. And that's all. We just keep doing that till we're done. For every group of 4, we swap with the top left corner and keep making progress in our loop. So the tricky part of the code for this thing, and what makes it a medium instead of something easy, is just indexing. The indexing of the elements in the array that you want to swap. And so, but again, pay attention. Notice how it's always this you're swapping with. So 4 is going to go with 12. 12 is going to go with 17. And 17 is going to go with 1. And then 3 is just 3. Okay, so let's take it from the top with code. So I have this setup right here, and what I want to do is point out a few things. So we're looping up until n minus 2, n divided by 2, sorry, half of n. Again, it's a square matrix, so the midway point of n is what we're looping towards. We're initializing column to what row is, right? And we're stopping it here. So this number, or this is important, n minus row minus 1 is what helps us like keep coming inwards. And then this is also important as well, because it gets us the rightmost thing that we've not seen before. And that, so this is very hard to intuit, right? To have intuition for, but it works, right? It's super effective. Probably if you were coming up with it from scratch, it would take a lot of trial and error, right, to nail down this relation. But let's look at it with a debugger real quick. I think it's useful. So we have this nested loop, right? The first array we're gonna, actually no, I didn't. My breakpoints disappeared. That's odd. Let's put one here, put a breakpoint here, put a breakpoint down here, so we can see what's going on. Get started. So in this case, we're evaluating what array? Okay, this 6 and 9, 2 and 7. Okay, and it looks like this. Oh, right next to my face. But this is it right here. Or you can pay attention to this over here. And so you notice, okay, row starts off as 0 and 0. So this is the top left thing, right? The leftmost item. That's what this is. And then this, on the other hand, right? The column is 0 as well. However, n minus 1 minus row is 1. So it's going to be Um, it is what we're doing is we're taking this, so column 0, right? The first column and the last row. Oh, I think this even has it inverted, but because it's top left and top right actually, then top left and bottom right, and then um, top left and bottom left. Okay, so we're gonna take this and this 6 and 9 and swap them. That's what this is gonna happen here. So top left and top right, 6 and 9, and this is how we index them. This is what makes the thing tricky, right? Figuring out this loop, this relation, but just knowing it exists can help you internalize what's going on here. So pay attention to down here if you can, and you notice that 6 and 9 swapped, right? Used to be this 6 and 9 over here, and then next we're gonna move what's on the top left and the bottom right. So this 6 over here and this 7 over here should swap. And what does that look like? It looks like this. This is what makes it hard to internalize, right? Figuring out that, oh, this is what how we index that value moving forward. And if you pay attention to it, don't blink. Boom. They traded places right here, and so on. And so that's all there is to this problem, really. You just keep doing that, and it's gonna go the way the diagram went earlier. I think you can run this locally, right? Run this in your own debugger, right? And there are some other ways to solve this, but I think this is like really efficient, right? Because there's only like literally only one loop. All the swapping is happening here. One nested loop. So let's just look at the time complexity for this problem. It's n squared, since again a loop inside a loop. It's kind of intuitively makes sense. And we're not storing anything new, so all of one. That's all there is to this problem. Like, comment, subscribe, share. See you next time.